Today we're doing medium problem 1673, find most competitive subsequence. Given an integer array nums and some positive integer, return most competitive subsequence of size k, meaning lexicographically smaller. Like this is like straight up ridiculous. Like they have this obscene explanation for why 134 is less than 135. Stupid. So now the point is, let's go digit by digit, right? And for first digit, what do we pick? Well, if we want to pick the smallest digit, but we cannot pick the last digit, right? Because then we will not have enough. So we can pick from 0 to n minus k, including minimum from that. And when we pick that minimum, then we have from here to n minus k minus 1, or if we subtract k, right? So, and that's it. And now how do we pick that minimum? Because, you know, k could be like, we could have like 1, 2, 3, 4, 5, blah, 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 up to n, and k could be n, then suddenly we would be n squared, which is bad. So how can we do this? Well, technically, we just having some sliding window, right? Because first we do this window, right? We pick this element, so we move window here. Here we have this window, we pick 2, and then we have this window. From that we pick the first 3, right? And then we have blah 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 this window, so we pick this again, and then we have this one, and we pick this. So now how do we do sliding window minimum with stack? So we keep them in increasing order from left to right. What does that mean? Well, when a new one comes in, new number, what does it mean? If it's smaller than the last element in the stack, then the last element in the stack will never be minimum for the rest of the windows. So we just kick it out. So we kick out end, and then we also kick out front, which is outside of the window if we move the window. And that's it. That's simple as that. You have a hard problem for free with this. So let's do that. Unstack, and then for num in nums, and then we do, well, we need some window LR, right? So let's go L this, and now we also need R. And now while r is less than n minus k minus 1, n minus k 0, 1, 2, so it should be less than or equal to, then we do this. While st and st nums st minus 1 is over nums I, then st pop while I guess that's it. St append r plus equals 1, and now that we are here, I guess we evaluate the answer, which is ans append nums stack 0, and then we do like I guess so we want the deque, not stack. Okay, so I misspoke there. my bad. And then stack or like I could call it DQ, right? Why not? DQ, DQ. So DQ, no, DQ pop left. Question is, do we even need L? Because I don't think so. I is not defined. Let's see. I think it should be 3, no? Because we had the 0. R1. Okay, so it's 3 here. Oh, I need to decrease K. Or like plus lens. We should keep decreasing sequence, right? So DQ3 we are at that. Then we should be at 4, so what am I even doing with this? While in ans K. Like this maybe. Okay. Okay. It's the very last answer. That's great. That is great. How come? Whatever, DQ, whatever we are doing that. Okay, that's basically the same thing. This is interesting. Just leave it in the cube. I mean, that's also an option. That's the whole thing. I mean, technically, I guess we don't have to do this, and then we just do this. Not really. I mean, let's just try to replicate it. So that's it, and then for while st and st minus 1 over num st pop st append num if len like this. I mean, that no, that doesn't work. While so while when stack is larger than Oof, I mean, let's say we have like so basically what we want to hold is that index is less than or equal to n minus k plus index. No. Okay, this should work. Nope. Okay. Now it works. Ah. Okay, 107. I guess you can do it with stack. Okay, so best pick for first digit is the smallest number. Best pick for second digit is the smallest number from let it be at index 0 is the smallest number from index 0 to n minus 1. Okay, and then one caveat is that this is not entirely true, since if the last digit is the smallest but k over 1, then we cannot pick the last digit as the first digit. We can always only pick from array nums, and now we'll have index I plus 1 to n minus k. K is 1, then it's not really n minus k, because then if we decrease k, we can always only pick from, well, that's for k like 4, so you I guess, yeah, that holds. just boils down to finding sliding window each time, throwing the minimum out. If we use DQ, we can now let's say we find minimum for from nums 0 to n minus k. How do we proceed without potentially having to rescan nums 1 and minus k? What is the smallest number? Okay, so we are building the sliding window, and we are at index I. All previous numbers that are larger can be discarded since they can't be minimum, because I will be smaller than or equal smaller than in all possible sliding windows. How can we simulate this easily? If we use stack, we first erase elements from top of stack until they are like nums, and then we can append nums to the top of the stack. Okay. We increase the size of the stack like this until we have okay, so one caveat is to not delete from stack if n minus k plus len stack I, since then we would erase from stack when we need to keep the elements. No. To solve the caveat from earlier, we simply have to not delete from stack if okay. We simply allow deleting from stack only if okay. Finally, the answer is the bottom k digits in reverse order top of the stack. On since each number is added and popped. Oh, I mean, is this really okay? Technically this, I mean, it could be. I could add like length less than k and this. No. Okay, it's on will be at most in minus k plus 1, I think. Stack worst case. Okay, that's enough stacking for today, bro. 27 minutes for medium is diabolical. See you tomorrow.